Hey guys, so we are going to go over our scientific method and hypothesis writing today. So if you missed our live, this is our video for that, okay? And this would be Thursday, August 20th. Yeah, Thursday, August 20th. All right, so here we go. This is the paper that you will need for your notebook. So make sure that you have that in your notebook, and it should be assignment number 4. And then I will show you also what our practice is going to be and what you'll need to do to let me grade it, okay? So this is our sheet for assignment number 4. Yes, and that will be scientific method notes. Okay, so what is a scientific method? Scientific method is a logical, organized mechanism for answering a question. It includes identifying a problem, researching that problem, developing a hypothesis, and creating strategy for solving the problem, all right? And make sure you're filling in your notes as we go. So typically the red highlighted words are going to be the answers for your blanks. So our first blank is going to be scientific method, all right? And we are going to go through this a lot this semester, but you are also going to see how important it is for all experiments to go through the scientific method. All right. So these are the steps of the scientific method. Let me take off my video real quick so you can see. But you're going to fill out your little chart on your paper as we go. So the steps of the scientific method. The first is to ask a question. Before you even ask a question, you have to make an observation, right? So you're going to observe something's happening or observe something, and you're going to ask something about that observation. Why is this happening? How is this happening? What is it involved in, or what is involved in this? Whatever your question is, you're going to ask that. Then you're going to do some research. Okay, you have to do research because one, what if somebody else has already done this experiment before? You'd be wasting your time and money and effort and everything. Maybe you need to know some background information on the animal that you're going to do your experiment with, or the element, or whatever it is. So you need to do some background research. Then you construct your hypothesis. So your hypothesis is very important, okay? And we're going to talk about that in just a minute, and you're actually going to practice writing hypotheses, all right? So your hypothesis is an educated guess, and it's educated because you've done that research. Then you're going to test your hypothesis with an experiment. So you run your experiment, you figure out what materials you need, you figure out what you're going to do, and then you run it. And then you get your results. So you're going to analyze those results, which includes data that you collected from your experiment, and then you're going to draw your conclusion. So when you draw your conclusion, you're trying to put together your data with your ideas to prove your hypothesis. Now, just because your hypothesis is wrong or you don't prove your hypothesis doesn't mean that it's bad, right? Because maybe you figured something else out, or maybe you just figured out that you went about it in the wrong way. That's totally fine. So if your hypothesis is true, then you're going to report your results, okay? So if you prove your hypothesis correct, you're going to report your results. Always share your results. If your hypothesis is false, or maybe it's just a little bit true, you're still going to report your results, but then you're going to go back and try it again. Now, not usually, all the time, you're going to do your experiment multiple times, at least 3, because what if your results were just a fluke, okay? What if it was just purely by accident that you got the results you did? So you want to do it multiple times so you hopefully get the same results twice, okay? So you want to do it until you get the same results at least twice. But if your hypothesis is false or it's not completely true, then you're going to go back and you're going to rethink your hypothesis. Maybe your hypothesis is right, but you did your experiment in the wrong way, or maybe your hypothesis is just completely wrong. So you're going to go back and do it again and reformulate some things. So the scientific method is not just linear, which means it goes in a line. It can go back and forth and go in a circle, okay? All right, now on to our hypothesis. So let me get my screen back again. All right. So our hypothesis is a proposed explanation made on the basis of limited evidence as a starting point for an experiment. Okay, so that's just a complicated way to say that our hypothesis is like our idea of what's going to happen if we do something. Okay, so if I walk outside in the summertime in Alabama, then I'm going to be hot and sweaty. Okay, because the temperature is over 100 degrees. All right, that's going to be my hypothesis. Is that always true? Probably not, but most of the time it is. All right, so that's my hypothesis. So your hypothesis has some parts to it. So a hypothesis should always explain what you expect to happen. It should be clear and understandable. It should be testable. It should be measurable. And it should contain an independent and dependent variable. All right, so let's go back. So explain what you expect to happen. So that means that, like I said, if I go outside in the summertime in Alabama, I'm going to get hot and sweaty, right? So that's what's going to happen. But I also have to tell why I think this is going to happen. So that's where I get the because. So because the temperature's high or it's over 100 degrees. You want to be real specific. So be clear and understandable. You don't want to just say, well, this is going to happen, and no reason or rhyme as to why. It has to be testable, which means you actually have to be able to run an experiment, okay? So it can't have opinion in it. So if I say Nike tennis shoes are the best tennis shoes ever for all sports, all everything, that's not really testable. I mean, we can test it to some extent, but that's my opinion, because Dr. Strode may like Asics, and Miss Brown may like Adidas, and Mr. Foy might like Under Armour, right? Because we all have different types of feet. So, and some things are just more comfortable to me than they might be to Mr. Foy. So that is testable to an extent, but not fully testable. There is some opinion base in there. It has to be measurable, so we have to be able to collect data on it. And then it has to contain an independent and dependent variable. And we're going to get into what those are in a couple of days. But your independent variable is what you are going to be testing. Okay, so that's what you're going to be changing. So in just a minute, we're going to practice that, okay? And this will make more and more sense the more you practice it and when we talk about independent and dependent variables. All right, so when you write a hypothesis, it has to be in an if, then, because format. So you're going to say, if this happens, so if what you're testing in the experiment happens, that's the independent variable, then you're going to predict what's going to happen, okay? And that's your dependent variable. So when in my example to you about going outside, if Miss Allen goes outside in the summertime in Alabama, right? So that's my independent variable, because I could go outside in North Dakota, or I could go outside in Canada, all right? So I'm going outside in Alabama, right, in the summertime, and then I'm going to get hot and sweaty. So my dependent variable is like the effect of what I did in my independent variable, okay? And then those things are going to happen because it's hot. The temperature is high outside, all right? So you're going to use background knowledge. You're going to use your research to tell me the reason why those things are happening, okay? So if this happens, or if this, then this is going to happen, and it's going to happen because of this reason, right? I promise it makes more sense the more you practice it, and we're going to practice it today several times. All right, so here is a practice. Erica baked a cake for her mother's birthday. When the cake was taken from the oven, Erica noticed that the cake had not risen. She guessed that the oven had not heated to the correct temperature. So Erica has a problem here, right? Her cake did not bake properly. So we have to figure out why her cake did not bake properly. So the problem is that her cake didn't bake properly, right? Now, we also have to write a hypothesis from our problem. So step 1 is, what is the independent variable for Erica going to be? So what is she testing in this experiment, okay? So her independent variable is the temperature, okay? Because we have not heated the oven to the correct temperature. So step 2, what is your prediction? So obviously, if the oven reaches the correct temperature, then the cake should bake properly. So it should rise. So what are you going to measure? Did the cake rise, right? And then what is your reasoning behind this? Because heat makes all of these things chemically react, and it makes it rise, right? So if I put the cake in the correct temperature oven, then my cake will rise because it makes the chemical reactions go, or it makes the yeast active, or something along those lines, okay? All right, so when we test our hypothesis, we have to design an experiment whose results will either support or reject that hypothesis, right? So we can't just say, oh, here's our hypothesis and we're just going to do whatever, right? Our hypothesis and our experiment have to go together. And the data obtained, or the data that we collect from the experiment, will either support your hypothesis or reject it. And just as a reminder, remember what I said earlier. If your data does not support your hypothesis, it does not prove it correct, that doesn't mean it's bad, right? That just means maybe we just went about it in the wrong way. Maybe our hypothesis wasn't completely correct, or maybe you just proved something else, right? That's how a lot of medical advances or a lot of scientific advances are made. It's just by accident. They ran an experiment to prove something, and then they did not prove that. They found something completely different. So it's totally okay. That doesn't mean it's wrong. That just means you're going to reject that hypothesis, or maybe that you just did your experiment incorrectly, okay? All right, guys, so now we're going to do our hypothesis practice. So this is the sheet that you're going to need for your hypothesis practice, and it goes in your notebook as assignment number 5, hypothesis practice. And what you're going to do is you're going to go through and read the question, and then you're going to make an if, then, because statement for each one of your hypotheses. If you don't know why, that's okay. I want you to reason through it and create a why. So like the because part, so if you don't know why something's going to happen, then make something reasonable to go with it. And what's going to happen is there's a linked form on Schoology, and it will ask you to fill in 2 of these on your on the form. So after you're finished with this, go on there and look for those. And you want to make sure that you do all 6, because you may have a notebook check where you have to go back and tell me something different than the ones that you're doing on the assignment today. So make sure you do all of them for good practice. So let's do number 1 together. So what amount of sunlight makes a daisy grow best? If I put a daisy in the sunlight for 3 hours a day, then it will grow the best because it is getting enough energy from the sun. All right, so there's your hypothesis. And in this, normally you would give a specific amount of growth that you could measure. In this case, since it doesn't tell us how it's going to measure growth, if it's size-wise, or if it's mass, or if it's height, you can choose if you want to. But since it says the best, we're just going to put the best, right? All right, go ahead and finish the rest of the sheet, and then go fill out your Google form for your grade. All right, I'll see you guys later. Bye.